My name is Rikard. I'm Swedish, and Swedish is Rikard. And I'm founder of a company called Clayster. We created our first IoT web portal 1997. So we've been doing it for quite a long time. And before that, we've been doing machine-to-machine communication and proprietary solutions to connect things remotely. So I want to start out basically by just going like quick through the internet, the evolution, and where we see that we are going. First, I just want to see, as the topic of my presentation is about XMPP. How many have heard about XMPP before? Jabber? Great. It's used probably by everyone. Today it's at least used by hundreds of millions of people every day. So the internet been around since like mid-60s. But in 1982, something like remarkable happened, like in looking into standards and what is going on. Basically, we decided to work with TCP/IP. And since then, TCP/IP been one of the most fundamental things to connect things to the internet. And it's quite obvious we are using the internet protocol. And it's, I think everyone can agree on that. That is something that is going to be around for like most of the times of the Internet of Things, if we're not going to call it something differently. And since like 1982 or before, but since then until today, we have managed to connect 12 billion things. And it's not that many if we think about what we are talking about on using the same infrastructure to do the same kind, but to put a couple of more zeros behind the 12. So, but back to the TCP/IP, what is it that it really does? It creates a self-healing infrastructure for nodes, endpoints to communicate, exchange information, and make that in a very intelligent way. So that is what we did. We've been doing all the time since the internet's been around. And but what have we then done out of it? What is basically the most remarkable things that we created out of the internet? The first application that came around was the web, and is still basically one of the only applications that we have on the internet. And it was 9 years after we created HTTP and HTML. And it's a pretty awesome thing. I think most people agree, and most people probably have been using it. HTTP was created to transport documents. We created HTML to make the documents attractive for people to play around with and to understand. And to make that easier for developers, we came up with the browsers. Later on, we created things to create native small applications. We have a lot of other SDKs that come from whoever it is. And but it's still about like sharing information for humans to interact on the internet. But I don't want to say that. I said before that the web is one of the first applications. Not really. We have been one of the first was probably machine-to-machine. And the machine-to-machine is, even though people who is in the IoT world thinks that is the coolest thing ever and that is something new that has been around, not really. Like machine-to-machine has been around since the day we created TCP/IP. We have been connecting things on the internet using TCP/IP for for as long as we have been basically playing around with the internet. But the problem with that basically is that we've been going through these wars of what technology should we use to make this happen. So we have a pretty, I think this is probably just a couple of percentage of what protocols we see out there and how we basically make the devices communicate. So in reality, what is the differences of IoT compared to M2M or M2M into IoT? M2M is not something that is public. It's something that's probably most of the time done in a closed, very secure environment. We are not taking advantage, or we are not using technologies that we could use to make it much secure. It's done it's a vertical. It's not a horizontal. It's solving one problem rather than opening up an infrastructure to solve more problems. So as I said, it's proprietary. And most of the things is about bringing something from a closed world into a remote management and whatever we want to do about it. So what is the new thing about the things, and how did that get into the concept for the rest of my presentation? The things is that we are seeing like a lot of more stuff that we want to connect. I think every presentation I've been to today have been talking about the Nest. That's the most remarkable thing ever. I've been in the energy management industry myself for my whole life, and connecting thermostat is like nothing new, but we have made it smart. They made it smarter. But the big thing is about connected to the internet. So what does it really mean to connect it to the internet? It's a question that we'll get into. And when we connect it to the internet, we basically connect the internet of things or the internet for things. So into this very famous year that we are getting closer and closer to, which I look very much forward to, which is the 2020. And by 2020, there is a lot of things that's going to happen. If you're in the energy management industry, there is a lot of things of saving energy that will happen by 2020. But in the Internet of Things industry, we are looking at these billions or trillions or whatever it is, the amount of devices that we're going to connect. We are pretty sure that there will be that it will escalate the number of devices that will be connected, and we're looking at 250 things per second. That is equal to 8 billion things per year. And if we bring that back to the context of today, the internet is living of 12 billion things. There is a lot of things that we will see in the future. We will almost double the amount of things per year. So what is the problem of how we are doing things today? The problem is that we see is that we are using the technology of the web and try to adopt it into the Internet of Things. In other words, we are doing the web of things. And how is that done, and what can we not see happens? By doing the model that we are doing today, we are seeing all these silos. We're not creating a horizontal infrastructure. We're not doing anything smarter. Having a lot of conversations with people that one of the problems of the Internet of Things today is that we basically are taking, I would say that we're basically, if the big data came after Internet of Things, things would look differently. The problem today is that we basically force the Internet of Things through the big data infrastructure and then out on the internet. And that is what we're doing here. The gatekeepers in this case of my connected devices on the internet is the vendor. The vendor is the one who is responsible and has the right to access my devices even though I don't allow them. And what do they give me? They give me an application and they say that we are open. Of course, you can have access to your devices, someone else have access. We provide you with an API. In my world, this is definitely not what the internet is about. This is still verticals. So what do we want? What do we want to happen for the Internet of Things? It must look like this. We must take the same structure of a semantic world and then put that into the concept of Internet of Things. And to make that happen, there are certain things that the internet must provide us. We must make the internet more intelligent. And for that, we need an identity. We want it to be in real time. We want to handle presence. We want to make sure if our device is online or offline. We need to secure the internet to be secure enough for people who is not allowed to speak with our stuff to not be able to speak to them. We need scalability and interoperability, which is a pretty important thing to secure for developers, so as for vendors or whoever it is to create their thing should work together seamless independently of the provider. And we need access management or access right management. We need to make sure that the owner of the device always knows who has the right to my real-time information. So what have we seen as the answer to this, and why did we go these directions that we've done lately? We came across XMPP now I would say 4 years ago, like 5 years ago. At that time, we had a customer who was in the building energy management industry, and they wanted to have something that made it easy for them to install products without the need of public IP addresses, to get away from the problem with IT organizations that don't want to open up the firewalls for them. They wanted to have something that was end-to-end encrypted and that kind of things. And that is how we suggested them start working with XMPP. And XMPP it changed the name in 1999 no, in 2001 to XMPP, when Cisco basically acquired Jabber. Before it was called Jabber. And Jabber was invented in 1999 and been proven since then. Most of the messaging information that is going on the real internet today is using XMPP. Google Cloud Messaging is using XMPP, Google Cloud Printing. And UPnP Forum, who we are working together with, have decided to bring all their gateway information into the internet using XMPP. So XMPP is well proven since 1999. I think there is, I don't know, there is statistic about how many hundreds of millions of nodes that is communicating every day in this infrastructure. And what it basically did when it came around was that it unified human communication on the internet. So now it makes pretty much sense that we should use the same kind of technology for the things to communicate on the internet. Why shouldn't the things have the same integrity protection as us as human being has? And the thing that I would say is one of the most important things to make Internet of Things happen is open standards. Everyone should be able to interact and be part of the standardization, independently if you are a billion-dollar company or if you are someone who is just interested to be part of this. And that is where XMPP Foundation and XSF, who we are working together with, is making this possible. They basically open up for everyone to let their word into this environment to say, is this good enough or is this not as good as we want it to be? And the standardization organization is basically about both the protocol for transportation, but XMPP, as it is an extensible protocol, also handles the data model or the payload for how messages is sent over XMPP should look like. And that's where we are doing work for IoT, which I will go later into the presentation. So basically, the things that we said before that we want to get out of a smarter internet is what we are getting from XMPP for free. We don't have to put like all these other things into the protocol to make it as advanced as we want it to be. Of course, you can choose to work with CoAP, which is basically just binary HTTP, and a lot of people very much agree that HTTP is not the best way to publish things on the internet. Or you can use MQTT, you can use whatever you want, but as soon as you start to add all the things that XMPP comes with default, you basically get up to the same payload, you get up to the same footprint or even bigger footprints, but you also get into a very complicated world where you have a lot of things that you have been proprietary. In this case, you basically follow IETF, so you're getting a fully standardized way of getting things to happen. And so this is basically where we are looking at putting we are doing it in Sweden right now, putting XMPP servers distributed out into the environment, basically as far as in the infrastructure, IP infrastructure as we can. So, and every XMPP server is basically federated, which means that they can communicate with each other. So you don't have to be at the same. So back what it also provides then is provides an identity, in this case, that is understandable for someone. You don't have to use your IP address. You basically get thermostat@clayster.com, could be the name of my thermostat. It handles and communication through firewalls. It is an end-to-end encryption bidirectional, which basically gives you the privacy that you want. And 6 months ago, every XMPP server that is on the internet, that is on the public internet, basically now is encrypted with TLS between each other. So there is no more looking into the messages going over the XMPP infrastructure. An important thing that comes to Internet of Things is to handle access right management. And for that, we handle XMPP. As for friends, you have to accept whoever you want to speak to, whoever wants to speak to you. The same thing for the Internet of Things. You have to accept whoever wants to speak with your devices. Yeah, this alarm company are allowed to speak with my thermostat or with my alarm system or whatever it is. And by that, we are creating infrastructure that looks like how we want it to be. We are creating an environment where things can communicate with each other seamlessly in a semantic model, where basically there is no more silos. There is an internet that is for things. That is not an internet of things. There is an internet basically where the things communicate together. And some of the companies that we are working with and that is working with XMPP, UPnP Forum has announced, and they, together with Samsung, says we choose XMPP because XMPP is well proven. Cisco run XMPP in like most of their products. Google use it in their cloud messaging, as I said before, which is used by billions or at least hundreds of millions of devices every day. And Oracle, Clayster, Coruscant, and KTC are companies that we work with also using XMPP. So more into, to go through here fast, what the interoperability part, because that is something that is extremely important in the IoT world. So what we do about that basically is that we created data models that is standardized by with the IEEE, IEC, and ISO within XMPP Foundation, standard foundation. And some of them that we have been working on is for the data model for sensor data, for control. And those basically describes how you communicate with a sensor, how you speak with a controller. Then we have something called concentrator. And concentrator is basically to take legacy protocols, like we call them, into the same data model, to translate them into this XMPP data model, and that is basically to take MQTT, C-Wave, ZigBee, whatever you have, or what you want, and get it into the data model. And then provisioning, which is basically to handle access right management in an interoperable way for devices. So sensor data, as I said before, like reading out sensor data. This I can look into. This is the messages, basically. It looks like how simple it is, the data model of how to get out the data. And then you have this control, which basically describes the messages of controlling in an interoperable way. Concentrator, which basically could be if you have your smartphone commuting BLE down to all your devices, and then publish them up into the internet using XMPP as well as the data models. And the last one that I had on my paper here, there is actually 11 different XCPs or SEPs as they are called. But this is the provisioning, which is all about the access right management of devices on the open internet. So, and for that, I can give you some brief. I just realized that my time is running out here, but it's pretty easy to get started using XMPP, which is also very good thing if someone who want to start playing with this, is just getting a Raspberry Pi, a BeagleBone, Google XMPP and IoT, and you will find a lot of things through XMPP Foundation's website. And in this case, you basically get an open source client. There is a lot of them. Shows the XCPs or the profiles that you want to work with. Some of them is already implemented, so you don't even have to do that. You just have to match that with your hardware device. Create an app, connect it to an XMPP server. Michael over there, he has an awesome XMPP server if you want to learn more about XMPP servers. And that is the whole thing. Like, you just create your app, connect it to the XMPP infrastructure, then connect your device, and the XMPP infrastructure take care of and handles the whole backend, whatever you want to call it, even though in Sweden we are right now creating the whole the internet is the backend in that case. And of course, as it is chat, you can chat with your devices. So in this case, I'm chatting with my thermostat in my home, send a message, how are you? And then it's in a standardized way published the information about how it looks, how it feels. And for those who are interested to learn more about the XMPP, we have put up a website that is think.me. And think.me describes all the XCPs, the standard. It's also an XMPP server where you can connect devices. There is a provisioning platform there as well that is available to connect devices to. So yeah, that was pretty fast run through the standard and where we are going, why we're doing what we are doing. So I have 2 minutes for questions. Yes?
How did you define the semantic model for all those things? I mean, or did you not? I mean, you were talking about the semantic web, you were talking about things understanding each other. I'm just curious how.
Yeah, the semantic model for XMPP or for the data model of the devices understand each other?
I guess for the data model, yeah.
Yeah, so that is defined by the XSF, and how it's defined, you can go in and look into it. It basically describes what a sensor is and describes how you control an actor or whatever it is. So I'm happy to share information with you if you want to go in and look into how it's defined. Yeah.
XMPP is XML, right?
Yes.
Are there any issues for low-powered devices?
Yes, so we work together with Toshiba and Siemens, and they are working with EXI. So, and EXI is compression of XML, and so they are using it in constrained devices. So we haven't seen an issue with that yet. And I'm happy to share more about that as well. And of course, it's an open community for people. So if you want to interested to get in, to learn, and to be part of these companies who is working with it, it's open. Yes?
Do you do two-way streaming of video for this? Is there any applications that...
The initiation, how it works with XMPP is that you don't stream video over XMPP. Then you basically, but you open up the connection, and then it's something called Jingle that is used for video chat, basically. Yeah. Okay. Thank you.